Today we're going to work through questions 1 through 20 just to make sure you know it and understand it for your final. So let's go ahead and do the first one. Alex, tell me what to do, please. Okay, remember your whole goal is to get that variable by itself. These two want to stay together as long as they possibly can. So I'm going to get rid of the negative 14. You are correct. You have to do plus 14. Keep going, Alex. What do I do next?
Divide by 9.
No, can't divide by 9 until I've done the work here.
54.
Okay, this is going to be 54. This cancels out. What else do I drop down? 19. Now you would divide by 9, and what's my answer? 6 is correct. Okay, so t equals 6. Basically what you can do is you can take this and put it back into here, okay? 9 times t, or 9 times 6. What is 9 times 6? 54, and then you would still minus 14. What's 54 minus 14? 40, and that's the answer that you wanted, okay? So for this kind of a problem, you can definitely go back and check it. Who did number 2 and thinks they know the answer? Kyla, help us out. What should we do?
Minus 6.
Good job. We're going to subtract 6 from both sides. Okay, there's two things there. We were trying to get rid of that 2 and the plus 6. You always get rid of add or subtract first, and then you always would keep that multiply or divide till the end because they stick together like best friends. Okay, go ahead.
12 minus 6 equals 6, and then you carry on the 2x. Then you divide 2, put 2x divided by 2, and then do the same thing on the other side.
Very good job, because we want to get that x by itself. And what does x equal?
3.
3. Once again, just to double check, you can stick this back into this original problem. 2 times 3 is 6, and then as you continue, 6 plus 6 does equal 12, so you know it did check out, okay? How many of you would say you got both of those correct on your review sheet? Excellent. Next problem, this asks us to make an input and an output table for the following function. Use the domain 0, 1, 2, and 3. Isabel, what should I do first?
Put 4 minus 4, negative 4.
All right, very good job. We're going to go ahead and rewrite this because I know I'm going to be putting in 4 different domains. What should I do after I rewrite it 4 times?
Replacing x with your domains.
Okay.
Which is 0, 1, 2, 3.
Very good job. We know that x, or the domain, is 0, 1, 2, and 3. So instead of having these x's here, I am going to replace it with 0 minus 4. The next one would be what, guys? 1 minus 4. The next one? 2 minus 4, because remember, you're just taking this right here and plugging it in over there. And the last one? 3 minus 4. Okay, Isabel, keep going. Let's do this first one. What is 0 minus 4?
Negative 4.
Okay, negative 4, and we know that that is going to be our y. And you can see right here is where we want to put that y. Okay, so negative 4. What would the next one be? What is 1 minus 4?
Negative 3.
Negative 3. And the next one, 2 minus 4? Negative 2. And the last one, 3 minus 4? Negative 1. Do you guys see here with this input-output table, do you see any kind of a pattern with your output right here?
Oh, that's negative 1.
You're just adding 1 each and every time, okay? So if you see somehow as you were doing all that, if at the end, this one, you ended up with something that was like negative 7, you would know that doesn't make sense, because if you have negative 4 to negative 3 to negative 2, and then you end with a negative 7, that wouldn't really make sense. So you can always look for some kind of a pattern. Number 4 is doing the same exact thing, but this time we have y equals 2x as our function.
So you're going to rewrite y equals 2x 4 times?
Okay, I'll rewrite it 4 times. And then what?
Then you would have to draw your input out to.
Okay, we're going to do an input and output table. We always know that this right here, the domain, is always going to be the x. That's always my input.
So then under x you're going to put 0, and then under 0, 1, under 1, 2, and then under 2, 3.
Very good.
Then you're going to replace the x with those numbers that are in parentheses so you know you're multiplying.
Very good. We do want to put it in parentheses, so then we know we're not going to try to add it or subtract it or anything else. We know for sure that we want to go ahead and multiply it. All right, so for that first one, we see that the y says it is 2 times 0. What would the answer be for that?
0,
Okay, and the next one?
2,
Very good.
4, and 6.
Okay, what kind of a pattern do you see for our output here, guys?
Add 2.
You're adding 2 every single time. So let's just imagine that I had a 4. Even if I don't do it, what would the next one be right here?
8.
It would be an 8, okay? Very good job. Those are just ways that you can double check your work and make sure you're kind of on the right direction, okay? So that's how you do an input-output table. For numbers 5 and 6, it asks us to solve the inequality and then graph the solution. Be careful with inequalities because sometimes we can wonder how to do it or forget how to do it. Just think of this almost like an equal sign, and then we're still just trying to get the variable by itself. Asia, how do I get that variable by itself? Okay, very good. We got to get rid of that multiply by 5, so we are going to divide by 5 on both sides. Okay, very good job. Now, do I need to flip this inequality symbol? I do not need to. Does anyone remember when I need to flip the symbol? Only if the last thing you do is multiply or divide by a negative number. So if instead this right here had been -5 and I had to divide by -5 on both sides, that is when I would have wanted to flip the symbol to look like this, but only if you divide by a negative number, okay, or multiply by a negative number. But I did not, so we're going to keep it exactly like that. That is the correct answer. Now, Asia, do you remember how to graph it? How many numbers do I put on my number line? 3. What number do I always put in the middle?
4. The number that you have got.
Okay, the number that was our solution, that will always go in the middle. Now, some teachers will have you make this number line forever long. I only need 3 numbers, okay? Now, what is 1 smaller than 4?
3.
1 bigger?
5.
5. Now, Asia, should this be an open or a closed circle? It is closed. Why is it a closed circle?
Because it has an underline over it.
Because it means equal to. That means 4 can also be our answer. Okay, so we want to put a dot on there so we know 4 can be a solution to that. Now, let's try to figure this out. Could I put 3 is less than 4 or equal to 4? Or could I put 5 is less than or equal to 4? 3. Okay, 5 is greater than. So we know that our answer is going to be going this direction right here. Now, there was a way that I taught you that you can always know to double check. Do you guys remember that?
No.
The way the arrow is going. See how the arrow right here actually looks like a less than symbol, and this looks the same exact way. As long as your arrows are facing the same direction, then you know you probably did it correct. Who would like to do number 6 for me? Jakari, go ahead.
So, you flip plus 4 on both sides.
Good job. We're trying to get that m by itself, so we have to get rid of the -4. So we add 4 to both sides.
4 cancels out, and 6 plus 4 equals 10.
Okay, do I need to change this inequality symbol?
No,
No, why not?
because it's not a negative.
Because I did not multiply or divide by a negative on both sides. Okay, so this is my answer. Now let's go ahead and graph it. What 3 numbers should I put there?
9, 10, right?
Good job. We know 10 goes in the middle, 9 is smaller, 11 is bigger. Is this an open or a closed circle?
Open.
It is an open circle. Then which one of these would be truthful? 9 is greater than 10 or 11 is greater than 10? The 11 is the one that's greater. So we have to cover over the 11. All right? Is this symbol done the same way as this one?
Yes.
Yes, it is. Okay, so you know you have graphed it correctly. Number 7 says to graph the following functions and use -1, 0, and 1 as the domain.
So, you have to do 1 equals 4 times negative.
Because we have that domain, we do want to go ahead and rewrite it 3 times. And you're going to start off with your input-output table exactly like we had done before. So you're going to have an X and a Y. And then you can see right here that it asks us to use -1, 0, and 1 as the domain. So that's going to be my X. All right, so Kyla, what should I do next?
Put parentheses around -1, the first one.
Okay, we're going to go ahead and get rid of that X, and we're going to replace it with what we said our X is going to be right here. So thank you for saying to put parentheses, because we want to remember we're multiplying by those. All right? So let's go ahead and start with the first one. What should I do first? Should I multiply first or should I add first?
Multiply.
Multiply first. According to PEMDAS, multiply comes before adding. All right, so what is 3 times negative 1?
-3.
Negative 3, and then add 1.
-2.
Negative 2 is correct. So that is going to be my output or my y. Next up, what is 3 times 0?
0.
Plus 1?
1.
Very good. And the last one, 3 times 1 plus 1.
4.
Very good. Okay. What is my pattern that I have going on right here, guys?
3 plus 3.
Add 3 every single time. All right, now let's try to figure this out. Basically, we could rewrite this is going to be the first thing that I'm going to put in here on my graph. So how do I get, if I start right here, every time we're going to start at the 0, and I have to go -1. Which direction is -1 for the x? Left is correct. Okay, so I'm going this way, and then where do I go for this -2 right here? You have to go down, all right? So remember, you're going left 1 and down 2, and then you plot your point. Next up, start at the 0, okay? Because this is the next set that we're going with. If I start right here, should I move left or right? Neither, okay? Because it says right here that I am going to stay at 0 for x, okay? Now, how do I get to this 1?
Go up 1.
You go up 1, okay? So this is 0 and 1. Final one is the 1 and 4. Which direction do I go?
Up 1.
Over
You
1.
go over
You always do left and right first, so go,
over 1.
which way is over?
Right.
Go to the right 1 and then
Up 4.
up 4. Okay, now what do I do?
Then you draw it.
You draw a line.
You connect the dots, okay? And that is how you graph the function. All right, for this next one, it's very similar, all right? So we're gonna go ahead, how many do I have in my domain? I've got 3 of them, okay? So I need to rewrite my original function right here, how many times? 3 times. Who wants to do this one for me? Michael. What should I do first?
You should copy that 4 times. 3 times.
Okay,
And then you want to switch the x to -1, 0, and 1.
okay. We do know that that is gonna be our domain, and we're gonna erase the x's right here and go ahead and slip them in, -1, 0, and 1. Now, as you're working through this, what is -1 minus 1?
Plus 1.
It's negative
Okay.
2.
Repeat after me. Same sign,
Add,
different sign, subtract, and take. Okay, so is that the same sign or a different sign? Same sign. Add the numbers, keep the sign. So what's the answer?
-2.
-2. All right, Michael, keep going. What's 0 minus 1?
1. And 1 minus 1 is 0.
Okay, I want you to look at the pattern here. As I go from this says to add 3 to get there. So that's adding 3. And this says to subtract 3. Does that make sense? Not really. So where did I go wrong?
Negative
-1.
Okay, let's go back to this. That's why you always want to check for a pattern. 0, if I have 0 and I take away 1, what's my answer, Michael? It's not +1. It's -1, okay? So make sure you keep that -1. Then, as I can see this shows me I added 1. This shows me I added 1. So you have to have the same pattern each time, okay? All right, so Michael, help me out now. The first thing I want to do is go ahead and plot -1 and -2. Which direction should I go for the -1?
Left,
Left, and then -2.
down.
Down 2. What do I do next?
You want to do 0 and -1. So it's on the y-axis.
Okay,
So you put a dot, no, you don't put a dot, but you go down 1.
go down 1. Excellent. And the last one is 0 and it's 1 and 0. Which direction should I go for the 1?
Up, not up, to the right.
Go to the right, and then
Dotted on
and then stay right there. Okay?
axis.
All right, very good. And that is how you graph the function. Any questions about that? Who would say you got that correct when you did it on your homework? All right, who would say you did not? That's okay. The goal is to have it for your final. Okay, let's go on to the next one. Katie, find the average speed and use the formula. What is my formula for average speed?
Distance over time.
Okay, A equals D over T, or A equals distance over time. What's my distance?
27 meters.
27 meters, and what's my time?
18 seconds.
Now remember, whenever you're finding average speed, this down here at the bottom, you want it to be a 1. How do I make that become a 1?
Divide by 18.
You divide by 18 on top and on bottom. When you do that, what did you get?
I got 1.5 meters per second.
1.5 meters per second. And that is exactly what we were looking for. Great job, Katie. All right, next one, Carlos. Find the average speed, use the formula. Tell me one more time, what's the formula? Okay, Carlos, what should I do?
You should 160.
160 feet. Always put those units over 5 what? Minutes. Okay, how do I get my denominator to become a 1? Divide by what? Divide by 5 on both sides. What do you get?
One second.
Okay, 32 feet per second. Very good.
My bad.
You are correct. It is per minute.
All right, Junior says sometimes.
Good job. All right, next up, finding the unit rate simply means you want the denominator to be a 1. JD, how do I do this one? Divide what? Okay, you have to divide by 9 on top and on bottom. And what do you get?
You get 500 calories per hour.
500 calories per hour is correct. All right, next one, Gabby. I've got $2.25 if I buy 5 pounds. But when you want to find a unit rate, you only want to know 1 in the denominator. So I want to know how much it would cost for 1 pound. How would I do that? You would. You divide by 5 on top and on bottom. And when you do that, what do you get? Okay, so it's 45 cents per pound. All right, any questions on how to find unit rate? Next up asks us to find the slope of the line and to use the slope formula. What is my slope formula? Rise over run. Okay, who can help me with this one? How to find the slope of this? Jakari. Okay, let's start from this point right here and get to that point right there. How many do I have to rise to get there? Count it with me, guys. 1, 2, 3. Okay, so I have to rise 3. And how many do I need to run over to get to this point? Just 1. Okay, can that be simplified at all? Yes. What can I do to make that more simplified instead of 3 over 1? What is 3 over 1? What is it? Huh? 3. Okay, your slope is 3. All right, you can continue coming up here and see 1, 2, 3. It goes up 3 and over 1. Once again, still up 3 over 1, up 3 over 1. You could continue up 3 over 1. I could continue and have another one, and this could have kept going. All right? Or how many of you would say you did it a different way? Emma, how'd you do it?
I went all the way up to 1 and 3. And there's one.
Okay. Which is totally fine. Here's what she's saying that she did. She figured out how to get from here up to that top point. All right? How many of you would say you did that too? Okay. How many did you go up to get up there? Okay, you went up 1, 2, 3, 4, 5, 6, and you went over how many? 2. If you simplify up 6 over 2, what is that? 3. So no matter what, you're still going to get that your slope is 3. Okay? Now, I want to remind you about something. When we have talked before, let's see, about different kinds of slopes. All right, if you have something that looks like this, let's just talk about the direction of these slopes. So let's say this one is going in an upward direction. Is that positive or negative?
Positive.
That's a positive slope. Let's say something is going like this. That's a negative. And then let's say something's going like that. That would be 0 slope. Okay, there's no slope on that one. All right? Let's talk about another one. Draw the graph of the line that passes through the points and then find the slope of the line. Who wants to come up to the board to help me figure out this? All right, let me have Katie come on up. The first thing you want to do is make sure that you have labeled your graph correctly. When you go to the left, it's always a negative. When you go to the right, it's always positive. When you're going down, it's always what?
It's negative.
Negative, and when you go up, it's always positive, okay? So it will help you to label your graph. Katie, the first thing we're looking for is 4 and 2. Which direction do I go for a 4?
So you'd have to go this way.
You would go to the right, and the 2?
You'd have to go up so you get right there.
Excellent.
Teachers, please pardon the interruption.
-1.
Okay, where is -1 at?
Close to you.
All right, you go left, and then
For -2, you go down.
you go down there. Okay, now what do I do?
Now you have to plot your slope, and so you would have to go up.
Okay, so we are counting, what is the formula for slope?
Rise over run.
Rise over run, so we're going to rise first, and what would it be?
1, 2, 3, 4, so 4
Okay, it went up 4.
over 1, 2, 3, 4, 5, 6. -6.
Okay, count again.
Wait, hold up.
Definitely 5.
Oh yes, sorry.
Okay, and you went over how many?
5.
Over 5. So what is your slope?
4, 5.
4 over 5. Okay, 4/5 is our slope. Any questions about that? Okay, does it make sense that our slope would be a positive slope?
Yes.
Yes, why?
You're not-
Because it's going upward, okay? We're not going downward, so it's going upward. We're doing the same exact kind of thing. Kyla's going to come on up. Remember, the first thing you want to do is always label your graph. All right, so Kyla, the first one we're looking for is -1 and 5.
You go over to the left one time,
Left once, and then
you go up to 5.
up to 5. Where's that at? Excellent job. Okay, the other one is 2 and 2. Where do I go?
Go over to the right 2 times.
The right 2, and then
And go up 2 times.
go up 2. Now what should I do?
Count 1, 2, 3.
Okay, we know that slope is going to be rise over run. So you've got to rise first before you run. Okay, now remember, it doesn't matter if we start with this and then we move up to that one, or if you would rather start with this and go down to this one. It doesn't matter. So where do you want to start, at the top or the bottom?
Top.
Okay, you're going to start at the top. You have to rise first. So is that left and right or up and down?
Wait, what?
If you're rising, is that left and right or is that up and down?
That's up and down.
Good job. So you got to do up and down first before you go left or right. Okay?
So you gotta start from the bottom.
Okay.
So 1, 2, 3.
All right, so you went up 3, and then for your run.
We're going 3.
Okay, did you go 3 in a positive or a negative direction?
Negative.
You went negative because you were going backwards. Can that be simplified at all?
Yes.
To what?
-1.
You are correct, -1. Now, you said that your slope was negative. When you look at this right here, does that look like a negative slope?
Yes.
Yes, because it's going downward, so you should know that your answer should be a negative. Okay? Now, once again, if you had decided to go right here, go down 3, that just would have meant your rise was -3, and then go over, that would have meant you had a positive. Still, your answer would be -1. How many of you would say you did get that correct on your own? All right, good job. Rise over run is the formula for finding the slope, okay? So that's going to be a formula that you for sure want to know. Next one, equivalent ratios. Using equivalent ratios to solve the proportion. Asia, I know this first fraction, and I am trying to get over here to this fraction, okay? I obviously do not know how to get from a 12 to the W, but I can figure out how to get from a 54 to a 9. Do you think I need to multiply or divide to get to that 9? You have to divide. What number should I divide by? Good job. Divide by 6. If I do that to the bottom, then I have to
Do it to the top.
also do it to the top. Okay, so in order to find my answer, what is 12 divided by 6? What is it, guys? 2. So that's your answer. W equals 2. Now, you can plug this in up here. 2/9. Can 2/9 be simplified at all? No, that's as low as it will get. I want everyone to take their calculator out, though, and put 12/54 into it. See if that can be simplified at all. Okay, when you simplify it, what's it equal? 2/9, okay? And that means this right here, when we plug that back in, it does equal each other, okay? So that's another way to kind of check how to do that. Let's go to the next one. Do I know both parts of my numerator and denominator on that one? No. How about on this one? Yes. So how do I get from a 20 to a 2? Divide by 10, okay? So we're working backwards, but if I'm going to divide by 10 on the top, I also have to do it on the bottom. So this just means 10 divided by 20 equals 2. 40 divided by 10 equals 4. So what is M?
4.
M equals 4. Okay, how many of you got both of those correct? Any questions? Please make sure you show work. I have to understand how you came up with that number. All right, for this next one, we're doing the same kinds of problems, but it asks us to use what to solve it? Algebra. Now remember, with algebra, all that means is get the variable by itself. What's the variable on problem 19?
F.
F. What is not allowing F to be by itself?
10.
Not just 10, but what?
6.
Divide by 10. How do I get rid of divide by 10? You have to multiply, okay? So I'm going to multiply both sides by 10. You could say by 10 over 1, because that means the same thing, or you can just do it times 10. If you times 10 on the right side, what do I have to do to the left side? You need to also multiply by 10 over here. Once again, you can do it over 1 also if that helps you, okay? So what happens over here on this side?
Equal to 1. Not 1, but 10.
Listen, you've got F times 10 over 10. What happens to those two 10s?
They turn into
These are going to cancel out because what is 10 divided by 10?
1.
It equals 1, all right? So this right here is no longer going to be there. And what is left on the right-hand side? What's left over here, guys? F, okay? We could do F divided by 1, but all that's left over there is just that plain old F, okay? Now we got to figure out the left side. There's two things that you could do. What is 10 times 6? 60. And what is 1 times 20? 20. If you were to simplify 60 divided by 20, what would it be?
3/10.
Not 3/10.
3.
3. Okay? 60 divided by 20 is 3. Now, some people would prefer up here to simplify it up top. How many of you simplified yours? Okay, let's figure out what can go into a 10 that can also go into a 20. What's the biggest number that can go into a 10 and a 20?
5.
There's something bigger than a 2 and bigger than a 5. A 10, okay? How many times can a 10 go into a 10? 1 time. How many times can a 10 go into a 20? 2. So now you have simply right here 6 divided by 2. What is 6 divided by 2? 3. So no matter what, you're still going to get the same answer. The next one, we have to actually put it into a proportion and able to be able to solve it. So how do I write as a proportion 5 is to 9 as x is to 18?
5 over 9
Equals x over 8.
Very good job. Okay, once again, it has asked us to use algebra. Using algebra asks us to try to get the x by itself. What is not allowing x to be alone?
18.
What about the 18?
It's dividing.
Divide by 18. What's the opposite of divide by 18? Multiply by 18. If I multiply this side by 18, what do I do to the other one? Also multiply this side by 18, okay? On the right side, what happens to those two 18s? They cancel out because 18 divided by 18 equals 1, and I'm only left with the x over there. Now let's come over here. Can I simplify either of those?
Yes.
What can go into both of them? A 9, okay? Not a 2. A 2 cannot go into a 9. How many times does a 9 go into a 9?
2 times.
Nope. And 1 time. And how many times does it go into an 18? 2. So now let's do 2 times 5 equals 10. And then you have down here a divide by 1, but you don't need that, okay? So what's the answer? 10 equals x, okay? So that is the first 20 problems. Tomorrow we're going to go over the next 20, but please use this to help you study for your final that you have next week.